Hello. Happy to be here. My name is Arman Nassirtoussi. I'm the founder of ElevateSoul.ai, which is essentially an AI platform for career coaching and startup coaching. And today we'll be talking about Agentic AI Ops. I come from an AI PhD background. I did 2009, 2014. It was about financial markets prediction using online news text mining. Hence, there was a lot of NLP components in it, and it's more than 10 years ago. So I've kind of witnessed most of the significant events in the AI in the past, 10 to 15 years very closely. And in the past 20 years, half of it I work at larger companies like Zalando and Henkel, and built data engineering, data science, and data platform types of teams. So I built the last organization I built was 60 or 70 data scientists, data engineers, data analysts, and we built a personalization engine for the context of e-commerce. I've also been for about 10 years as a founder, doing multiple different startups, and the one that I've been busy with for the past couple of years is ElevateSoul.ai, which is the AI platform for career and startup coaching, as mentioned. When we talk about AI ops, one way to look at it essentially, that it is data-driven DevOps, right? And if you want to look at things from the AI ops perspective, these stages, these 5 stages, are kind of well known. You're probably familiar with it. That we have the ingest phase, we have the topology, we have the correlation, recognition, and remediation. And we can look at least from a data perspective, from an AI perspective, at the different steps that occur for AI ops, through this lens. And from all of those stages, really, if you want to kind of focus on how machine learning might be used, you kind of look at these two, the correlate and recognize. So ingestion is, there is that data collection and ingestion, right? Topology is, how you map the different systems together so you can kind of declare the different relationships between different components in the systems. And correlation then kind of correlates the different events. And recognition is when you detect, for example, an anomaly or the reason for an alert. And remediation is when you actually take on an action to solve the problem. So from these 5 sort of stages, I submit to you that ML, machine learning in this kind of a traditional sense, can be and has been to an extent used in correlate and recognize. And of course, machine learning from a very large, kind of from a big picture perspective, you can always think about like supervised learning and unsupervised learning. And for supervised learning, of course, you need sort of labeled data, and which is hard to combine in the sort of DevOps AI Ops type of a context, but it's not impossible. There are examples how you do, for example, for incident classification, you use supervised learning, but of course you can also use unsupervised learning. And I think most of the cases are as such that you kind of rely on clustering mechanisms to identify abnormalities, anomalies, or potential classes of activities that are happening in your data. And if we kind of just reflect on this for a second together and say, okay, what could be a use case that traditionally in AI ops machine learning could have solved, like mentioned, grouping of traces, logs, or alerts. Sometimes that requires, of course, this kind of a semantic analysis. So there is a certain level of semantic analysis possible in the context of machine learning. And in certain cases, it's been applied in the AI ops context. So for those purposes, we can come up with examples in the correlation and the recognition space. And we always look at machine learning, from this lens of supervised and unsupervised learning, as we mentioned, and each of those types of machine learning enable a set of things, but primarily if you're interested in a particular set of classification, let's say, of the alerts, or what we see in the logs, etc., then we can use, or the common algorithms in AI ops have been used, and a certain level of organization and decision making has been automated in that context. However, if you look at the general problem space for AI ops, including the people involved in the AI ops, and if we look at that end-to-end workflow that I showed in the beginning, there is a number of, and I call this the kind of the AI ops understanding problem space. Yeah, there is a lot of situations where you require semantic understanding, you require contextual reasoning or understanding, temporal reasoning or understanding, something that I call multi-signal synthesis, and then there is many cases of decision and planning and knowledge and workflow application that are currently conducted by humans. So let's look at these one by one. So semantic understanding, when we wherever we have text, it can be in the logs, traces, in the context of a ticket, in an alert. If we want to establish semantic similarity, and sometimes the semantic similarity is because we want, the meanings have to be close to each other. Sometimes because of, typos, spelling errors. There is a lot of noise and duplication that exists in such spaces. And this is the type of thing that usually a human being has been, even in the context of the AI ops, providing input about. Additionally, there's been a lot of need for this kind of a human intelligence to understand the overall context as to what are the other operational activities that might be underway or happening. If there is something even on the business side or on the marketing side, or has there been any sort of recent deployments on the tech side? Has there been any configuration changes? Are there maintenance windows that we have to be aware of, etc.? So all of those things, you can think of them as contextual sort of events that are either on the operational side, or they could be also about an environment. So if you have a code base or a piece of the technology in that context, you want to know certain things about that environment to be considered. Those things are usually in people's heads, and or they're in some documentation, and they are needed to be considered at the time of these DevOps operations, AI ops operations, especially when there is a situation which is intended to be remediated. A third group is when things are happening, right? So let's call it temporal understanding. On our timeline, when did a particular deployment take place? or if we have a situation or a certain type of an alert, what are the things that happened before it? What are the things that happened after it? So even in the best environments, you can have monitoring of these things. You can have observability. You can have monitoring of your applications. But at the end of the day, a lot of these decision making is in the AI ops context in a sort of the routine fashion, or decisions that need to be made by the people who are involved in that context. And they're also difficult decisions to be made because all of this data is also not necessarily easily available to the DevOps colleagues or the AI ops colleagues, and it might be partially available, or even if they're available, like what kind of decision workflow or flow is needed to be pursued in the case of need is not always super clear. Experience plays a role, etc. Right? So those three, semantic, contextual, and temporal, are just sort of three, I call them areas in our overall problem space when we look at it from an understanding perspective, from a decision-making perspective, from an intelligence perspective. And of course, there is also a meta level of analysis, and there is also a meta level of synthesis that, because just having that semantic understanding among the tickets or the contextual understanding or just the temporal understanding alone is not sufficient. So hence, what is eventually also needed is kind of an analysis that is in a meta-analysis in nature, which in this case we call the meta-synthesis. So that's sort of the fourth one. And then, even if all of that understanding exists, then we need to be able to decide, do we restart a service, or do we scale it up, or do we, roll back a deployment? So there are decision points, and there is a decision component in the problem, in the sort of this understanding problem space of the AI ops that can be observed, or if a topic needs to be further escalated, right? So these are, components that appear when we are dealing with the day-to-day areas of work. And of course, once we have observed everything we wanted to observe and we've done all the planning and decision making that we need, then we have to have the ability to actually take action, which we do. So as engineers, we go and carry out, runbooks or playbooks or remediation scenarios, etc. Right? But that execution step itself is also something that shapes a large part of our work in the DevOps or AI Ops context. And if you look at the problem space in that form, it becomes clear that for each of these areas of understanding that I mentioned, the existing, up until a few years ago, a couple of years ago, machine learning or AI that existed is not relevant, is not sufficient. Of course, you can try to create some kind of a supervised or unsupervised machine learning algorithm to try to address any of these things in a very specific context, but usually that does not justify the required costs. And it becomes super custom, and usually the outcome of it, the net gain is not super high. So this, what we as engineers brought to the table is this general intelligence that helped navigate or steer these steps throughout those specific components where those pieces of understanding were needed. And what has happened, to the shock and awe of all of us, is that we have had this phenomenal breakthrough in AI with the inventive sort of Gen AI in its current form, which stands for generative AI, but what it actually is kind of general intelligence, meaning that the same algorithm can solve different types of problems without any customization. And that's the reason that you can ask ChatGPT any question about any fields and you get an answer, right? And it can vary from, in sort of different spaces of understanding, and you still get what you need, and the input data can vary, and the context might vary, and the expertise required might vary, but there is basic kind of the DNA of intelligence, the DNA of understanding is shaped in such a way to an extent that allows generative AI, or this form of general intelligence that is now available, to address what we need in the semantic context from a language perspective, which could be grouping 200 log lines, as in that example, or observing a temporal evolution of a topic, or understanding the context given that there is these operational or environmental context, and what could be the right decision. Any of these things, if you put in ChatGPT, and if you put the required data into ChatGPT, you can get an assessment that is somewhat robust. So the context is to be provided, but the intelligence operates very well independent of the context, which then allows us to make decisions. So it essentially very effectively supports our decisions in each of those areas, as well as conducting a meta-analysis or meta-synthesis on all those areas of understanding that are required in the day-to-day. So that's what has happened. That is the breakthrough. And so hence we have this ability to create sort of to understand, or we have created an algorithm that demonstrates understanding in a fascinating level, let's say. So that's one piece of the puzzle. But of course, that in itself, in an isolated fashion, in a day-to-day operational work, cannot provide enough value. Even if I ask a question and get an answer, even that provisioning of the answer, there is a component of execution in it, right? It has to act, it has to provide something. So that gap between understanding and execution still kind of exists, despite the existence of Gen AI, form factor, especially, let's say, the large language models or the LLMs. And in order to close that gap, a new form factor has been defined, namely the agents, with their current definition, meaning that you have essentially a piece of software that at its core has got this Gen AI or general intelligence or this LLM, and then the software helps organize the needed prompts for a particular context, or it provides the needed data according to an available context, or the memory, or even tools, etc. And the agent can then provide the answer or even take further action, right? So that's the definition of the agent. So we talked about kind of ML, what ML can do. We kind of transitioned to what is meant by this kind of general intelligence and what Gen AI can do. And then we transition into, what an agent does, which is essentially, and what an agent is. And this sentence, AI is the new electricity, is very is very kind of relevant, is very appropriate, because the mental model for us could be that each of these pieces of software are very much like, a washing machine or electrical appliance that is kind of using electricity to do something. Now, these new pieces of software that we call agents are essentially using or tapping into this intelligence and are then, software packets that are doing things, right? And that way of thinking we call the agentic AI, which is essentially an architecture. It's essentially a software architecture that allows software workflows, logic, to natively and effectively use LLMs, let's say, at its core in a particular common form factor, to do planning or to do orchestration of activities or to decide what particular tool to call or what particular API to call. So this is, this gives rise to this huge revolution that we have in context of the agents. One interesting way to think about it is that if you look at how our brain operates and the overall intelligence that we have, and if you've read this book, Thinking Fast and Slow, we have the fast thinking, which is our intuitive thinking, and we have the slow thinking, which is kind of our logical thinking. And that fast thinking, that instant pattern recognition, is very much similar to what the LLMs offer. And that slow thinking and kind of essentially consciously think about something and keeping things in memory and going through a logical flow is what actually software is capable of offering. So we're kind of wrapping that software around that intelligence. Okay, so I think this, from a metaphoric perspective and both realistic perspective, is also a good mental model to carry from an architectural standpoint, and can then arrive at, okay, when we have an agent, it has this LLM at the center, and this so-called agentic layer that can do these things, but these things are the things that software can do, but we're just at the appropriate times calling the LLM to enable us to, for example, make a decision as to what tool to call or what API to call, etc. Right? So that's the source of intelligence. And this can also be looked at from a different perspective. And Andrej Karpathy has this software 3.0. And I think that because we have this software 1.0, 2.0, and 3.0, that can be applied in all areas where we've had software, including AI ops. So 1.0 could be understood as, basic usage of data, rules and dashboards, etc. In 2.0, we're actually using some of the supervised and unsupervised, or as much as the machine learning can offer, but that's a very small part of the overall problem space. And then now with this agentic AI architecture that we discussed, that we call AI Ops 3.0 to follow that Andrej Karpathy's model, then we can actually apply intelligence to many other aspects and to all the different steps of our workflow, right? So even at the ingestion time for enrichment possibilities, for instance, or in the topology definition or understanding or formation, but of course, significantly in correlation and recognition. And with the additional capabilities also now into remediation that we can talk about. So if we look at an example, in a manual context, an alerts fire, there is high latency, there are some errors in service, engineer reads logs, checks topology, correlates manually, decides and runs scripts, and each of those aspects or actions on the left are now feasible to be done using an agent or multiple agents on the right. So agents can summarize logs, agents can interpret logs, can correlate signals, can diagnose contextual sort of circumstances or symptoms and kind of correlate them or create a diagnosis and propose a fix. And then also they can trigger pieces of software that will then do things, which then brings about that kind of an execution component or the autonomy component. And hence, if we think about it's thinkable to have like almost like a reference architecture that puts all these different components together, but essentially, we have to think about it from a maturity model perspective. And just like any other data types of an activity, you have to have data readiness, and then you can probably apply it, or you can have an agent or a few agents that are kind of focused on detection, and then maturity increases at some point. We can go to insight, etc. So the rollout of it is very much like the data-driven activities, probably faster, but still requires a maturity model. But what, in summary, I hope that stays with us and I submit to you is that in all of those components, analysis, detection, decision-making, and execution, this new form of intelligence can have an impact, and that is what is then shaping the next generation, which we can refer to as Agentic AI Ops. If we have a couple of questions, we still have a couple minutes. I appreciate your time and happy to stay in touch on LinkedIn. There's one question: where does Agentic AI Ops generally outperform traditional automation today, and where is it still adding complexity without enough payoff? So those three forms of software, if one understands them, is key in answering this question. There is normal software, which is like normal workflow, normal algorithm, normal flowcharts. And then there is machine learning, and now there is agentic. And agentic, because of the decision-making nature that it's offering, so you can kind of, so for example, you want to do a sentiment analysis, or you want to say, what is this ticket about? Or what's the likely problem? You can just give it to ChatGPT and you say, these are 10 likely problems. Without any training, it will tell you which one it is. So as a result of it, you have a decision point mechanism that you can then use in your control flow, which we can then refer to as agentic control flow, which then enables that automation. But fundamentally, automation and intelligence are two different concepts. Proper intelligence, which like the one that we have, can give rise to automation, but it's good to think about them as two different problem spaces, and the actual automation to a great extent can be solved by normal software, but just the decision flow was the problem. I hope that helps. If there are any other questions, I'll be happy to take them. If not, we are approaching the time.
Yeah, thank you very much, Arman, for a great presentation.